Have you ever tried to solve a really hard problem by brainstorming a bunch of different solutions and then picking the best one? That's exactly how we often try to make large language models, or LLMs, better at complex reasoning tasks like advanced math. The strategy is called best of n. You make the model generate n different answers and then use a verifier to pick the correct one. But this leads to a huge, expensive question. What number should n be? 10, 50, 100? For a long time, the answer has been little more than a heuristic, a fancy word for an educated guess. This means we are likely wasting enormous amounts of computational power and money by either generating too many samples or failing to get the right answer by generating too few. This is the exact gap these researchers decided to fill. They wanted to replace the guesswork with a principled, mathematical foundation. Their paper introduces a probabilistic framework to formalize this process. The core idea is that if you can estimate the probability of a model getting a specific answer right on any given try, you can then calculate the minimum number of tries required to achieve a certain level of confidence in your final answer. They figured out the theory to determine the perfect number of samples, providing the first solid guidance for how to scale up an AI's reasoning power without wasting resources. Building on this theoretical insight, they developed a practical algorithm they call OptScale. Here's how it works. Instead of asking a powerful, expensive LLM to generate a fixed, large number of answers for every single problem, OptScale uses a smaller, faster, predictor model first. This predictor quickly analyzes the problem, say, a complex algebra question, and estimates how likely the main LLM is to solve it correctly on a single attempt. Using this probability, OptScale then calculates the optimal number of samples the big model should generate to meet a predefined goal, like being 95% sure of finding the right answer. For an easy problem, it might ask for just 1 or 2 answers. For a monster problem, it might ask for more, but never more than is statistically necessary. The team tested OptScale on famously difficult mathematical reasoning benchmarks, including Math 500 and GSM 8K. The results were clear. OptScale significantly reduced the computational overhead, the number of answers generated, while performing just as well as, and sometimes even better than, state-of-the-art methods that blindly generate a large, fixed number of answers for every problem. This demonstrates a powerful trade-off. By adding a little bit of intelligent prediction up front, you can save a massive amount of computational work on the back end. Of course, the system's effectiveness relies on the predictor model's ability to accurately judge a problem's difficulty, but the findings show this is a highly promising path forward. This research shifts our thinking from more is always better to just enough is optimal. It begs the question, how many other areas of AI are we applying brute force and guesswork where a more principled, probabilistic approach could lead to massive gains in efficiency? If you enjoyed this breakdown, don't forget to like, comment, and subscribe for more AI research made simple.